Good morning, everyone. This is our last unit this week. Yes, this is our last week. The final will be next week. And this unit kind of, once again, ties together stuff that we've talked about, at least briefly, or you're aware of before, goes into a little more depth, but puts it all together. So once again, it's going to tie together a lot of the concepts that we've already talked about in some of the other units. So this unit is about solutions. And I'm looking at my D2L here. And solutions, really what we're talking about here is concentration. I mean, a solution is basically a mixture of stuff, a homogeneous mixture of stuff, where the particles that are the solute that are in the solution, in the solvent, dissolved in the solvent, are so small that we can't see them. They're homogeneously mixed throughout the entire solution. And the question is, and the thing we have to really understand is, why do these things dissolve? And so that's going to be something you're going to have to kind of understand, and we need to really focus on what makes something dissolve. If I take a piece of rock and throw it into water, an aqueous, trying to make an aqueous solution, will the rock dissolve? Well, no, probably not, depending on what chemical it's made of, but no, probably not. Why? Because the particles and their individual particles of the rock are so tightly held together with intermolecular forces that they cannot be torn apart in the solvent of water. At the same time, you could look at it another way. The water, which the rock's going to probably go to the bottom, the water which is floating on top also cannot be separated and come apart. It's all about a tug of war between these intermolecular forces. Okay, let's say you take some salt and you put some salt into water. The salt will dissolve. You'll no longer see those crystals. Why is that? Well, the salt, the sodium ions and the chloride ions, the Na plus and the Cl minus, are not so tightly attached that, well, they're so weakly attached, I guess, in a way of saying it, that the water can separate them. They're more attracted to the water than they are to each other. So they dissolve. But now we know very well that if I were to take a big pile of salt and one drop of water, the salt would not dissolve. So even though we say sodium chloride is soluble in water, there's a limit to that solubility. And so how come after a while can the water not pull it apart anymore? And so we need to see this on a molecular level. That's the object of this unit. So we have these attractions between the solute, the salt in my example, and the water. And somehow the water, the solvent solute attraction, the water salt attraction is great enough to pull that salt apart. Well, how much salt can it pull apart? And we call that concentration. There are many different ways of measuring concentration. And in my mind, and excuse me if this is not exactly correct, and I wouldn't go on repeating this somewhere, it's kind of like density. Density is how much stuff, how closely packed together things are. Concentration is how much stuff there is in our matrix, in our solvent, how close they are together. The more concentrated it is, the more solute stuff, sodium ions and chloride ions, there are in the solvent. We can measure that using different units. One of them is molarity. One of them is molality. We can have percent composition or percent by mass, percent by volume. There are other ways as well, which we're going to need to be exposed to in this unit, and we use them in different environments, different situations. Well, why is the concentration important? I'm going to just leave it at this for the moment. I'm going to leave it in that we have, for example, when it's icy out, it's spring now, but when it's icy out, we throw salt on the ice, which helps the ice not freeze, or the water not freeze, I guess. And so that is what's called a colligative property. Colligative properties depend completely on the concentration of the solute. And we're going to explore these colligative properties a little bit. And in fact, our lab this week is going to be about a colligative property, boiling point elevation. You're going to do a lab. It's not an HOL. This lab you're going to print out, you're going to do on paper, and you're going to turn in as a PDF. You're going to use your HOL equipment, but you're also going to need some salt, as we speak of it, that you're going to have to get yourself. In any case, print that lab out, do it carefully, Be very conscious. We're at the end of the semester now. Significant figures are critical. So be very careful with your quantities, your masses, and your temperature readings. It's kind of repeating a lab we've done before, but in a slightly different way. Boiling point elevation again, but that'll be due on Sunday. Also on Sunday, your mastering chemistry will be due. There is no assessment this week. We need to use this week to get prepared for the final. Again, it reviews a lot of materials. It ties together things. Hopefully you're starting to see a bigger picture. If you're not, or you're still confused, you need to talk to me. This is our last week to talk about grades. Will I have everything graded this week? I hope so, but there's no guarantees. Obviously, the stuff due this week won't be graded. The final exam, we'll talk about that next Monday morning. But you need to prepare yourself with the final exam review materials. And you need to get all of your late work done. If there's any incomplete work or work that you need to do, that needs to be completed by next Sunday night. When you complete work that's already been graded, that could be labs, that could be mastering chemistry, that could be anything you turn in, you need to send me an email. And in that email, in the subject line, you need to tell me what it is you've completed. I have no other way of knowing that you've completed something to add it to your grade. And it may not be added to your grade this week, but I recommend, I suggest, I implore you, do it, because it'll help you review, it'll help you learn more stuff, which is the idea of this course, and it'll impact your grade, which I know is important. So complete any work that's incomplete that needs to be completed by this Sunday night. I will not accept work after this Sunday night at midnight. If you have any questions about the course in general, about what you need to do, about content, please contact me. One last thing, please complete the course evaluation. You should have gotten information from Oakton about the course evaluation. Please complete that. It goes to, I don't know who the powers that be or whatever, but it also goes after the class is over to me. So I can get some feedback on what worked for this view, what didn't. The more comments you can make, the better. It's very helpful to me, and it's very helpful to the school for all your classes to kind of have a gauge of how the class is going. Again, if there's ever anything you need to talk to me about or ask me about, or if you have a suggestion, please give it to me directly. But the course evaluation is another way to do that. And again, I'll get that in a few weeks after the class is over, after the grades are in, after everything, to give me some feedback about what worked for you and what didn't work. So we will have one more Monday morning meeting next Monday. Hopefully you will be there. Hopefully I will hear from you during this week about questions you have about the content and feedback about the course and everything else in general. So thank you guys, and I hope to talk to you again soon.